Hey guys, I'm back with some more science. Um, Today this is a thing where they got gases to bounce off of each other. I know it sounds weird, but it's really cool. They did it at MIT, and they took an isotope of lithium here. It's in the fermion category, and they cooled it to, I think say down here somewhere. They cooled it to yes, 50 billionths of a degree Kelvin, so almost absolute zero. And at that point, they bounced off of each other. It took them a second, as it says here, but wow, that's quite a while for something like that to happen. And yeah. And then what they did is they took magnetic forces and they separated them, and then they made the clouds collide, formed by laser, and instead of passing through each other, like normal gas clouds would, they repel each other, which is, um, you know, wow, that's crazy. And yeah, and the um, I'm amazed that the gases could bounce off of each other. I'd really like to see where this goes, and if they can actually get it to work in the the second dimension or not. So, yeah. So what they did was they recorded. They wanted to model extreme, very strong interactive systems. So they got lithium gas atoms that were cooled to basically absolute zero, almost. And they still did it for electrons. They're in the same category, fermions, at this point. And they used the magnetic field to actually switch the states from solid to liquid to gas. Because, as it says up here, they're distinguished by their mobility. So by changing the magnetic field, they can change the mobility. And then they made them interact with each other as strongly as they could possibly allow, so that they would scatter every time they encountered another one, like make an explosion type thing, although not an explosion, but they would scatter. And so they grouped them into spin up and spin down categories, and then they collided them, and they would scatter off of each other. So they actually got a gas to bounce off of another gas. I mean, this is by far not a normal circumstance. As they said here, they're pushing the laws of physics. They're as strongly as, you know, as strongly as they're, as possible, really. So, yeah, but I'd like to see where this goes and what it could actually mean. Like, if this is possible, like there's places in the universe where the temperature is 1 degree Kelvin. Is it possible that two giant gas clouds could collide and instead of absorbing each other over millions of years, bounce off of each other? Um, you know, it took them an entire second or more for just 100,000 atoms or so. So think about in something like a giant thing, it could take years for them to bounce off of each other and collide. And this was in a trapped environment, so who knows, they could bounce off each other and keep going the other way. So I would really like to see if something like an infrared telescope or something could actually capture something like that, see if it's actually happening in the universe. But once I get this simulated in 2 dimensions, that'll be really interesting to see how electrons actually behave in semiconductors, or superconductors, sorry. So, that'd be really interesting to see. And then also another thing that works strongly is quark gluon plasma, and so they could do for that. But this is really interesting, and you really ought to read about this yourself.